Welcome to an Achieving Science video. This video is part of a set about balancing equations. Let's begin by looking at a compound first of all. If we take a simple example being water. Water, as you're aware of, is made up of hydrogen and oxygen, the two main elements. We can represent what's happening in the formation of this compound via a word equation. This is where hydrogen reacts with oxygen to produce water, where we have the reactants, hydrogen and water, on the left hand side and the product, water, on the right hand side of the equation, with an arrow separating the two. Now let's work out a balanced symbol equation for this reaction. Well, as you're aware, hydrogen has a symbol H, oxygen has a symbol O. But both of these elements are found as diatomic molecules. Di meaning two. This means that they go round in twos. So therefore, they are not H plus O, but instead we have H2 and O2. Now it can help to understand this balancing equations by drawing out what we know. So we can draw these. So hydrogen H2 is two hydrogen particles joined together, two hydrogen atoms. O2 is therefore two oxygen atoms joined together. If we use different colours, we can therefore show what happens to them during their path. We can also draw a water molecule, which is H2O, meaning there are two hydrogen atoms joined to one oxygen atom. Now let's write it as an equation. So we can put the plus symbol in for that between the hydrogen and the oxygen, and the arrow between the reactants and the products. There is a problem, as you can see in the diagram above. Before the reaction, there are two hydrogen atoms and two oxygen atoms. And then after the reaction, there are two hydrogen atoms, but only one oxygen atom. Therefore, what we had before, we haven't got after, because we've lost something. We've lost an oxygen in this case, so there is a problem. So now we need to look at a solution to this problem. And therefore, if we begin by looking at what's happening again, we can work out a solution. Because in every chemical reaction, whatever we have before, we must have afterwards. So if we've got two before, we must have two afterwards. If we've got four atoms before, we must have four afterwards. We must account for absolutely everything. So let's begin by drawing out the equation again. Now what we can do is we can add another water molecule. We can't add another oxygen to the water molecule because that will no longer be water. So therefore we must create another molecule. So let's draw that out. And if we now count up, we find out that we have got four hydrogen atoms and now two oxygen atoms. Now we can work out what we're short of. Well, before we had two hydrogens and two oxygens. So therefore we are now short of hydrogen, and we're short of hydrogen by two hydrogen atoms. So simply now we can draw another hydrogen molecule. Again, because it's diatomic, it's H2. And now we can count up all of these hydrogen atoms and work out that there are four hydrogen atoms instead of two. Now we have the same number of hydrogen and oxygen atoms before and after the reaction. Four hydrogens before, four after, two oxygen atoms before, two after. We can therefore now summarise this in a balanced symbol equation as 2H2 plus O2 gives you 2H2O.